Hi everyone, this is Editing Helena here from the future. I hope everybody had a great weekend. Since we had a few technical issues in the beginning of last week's Tech Talk, we just kind of ended up jumping straight into the presentation, which was great in that moment. However, for this recording, we definitely want to do things the right way and give our guest the introduction he most certainly deserves. So please, everyone, welcome with me, Vasu Chandrasekhara from SAP. He also works as an advisor for the NeoNephos Foundation. And he's here today to talk about sovereignty. And thank you so much for joining us, Vasu. And without further ado, we are going to jump straight into a presentation that I can already tell you is going to be a great one. And yes, enjoy.
Thank you for coming to my talk. Sovereignty is a function of ecosystems and interoperability. Today, my name is Vasu Chandrasekhara. I think some of you may already know me. I have been for quite some time at SAP. I was the CPO, Chief Product Owner of the IPCEI-CIS project, Apiro reference architecture, but I'm now with the NeoNephos Foundation, which I initially also started. All right, the agenda for you I basically put together also in the abstract was originally like this, that I'll talk a bit about the background of the IPCEI-CIS, the motivation that's coming out from the Draghi Report, and why we had to create NeoNephos. And then I would have wanted to go into some technical concepts with demos. But then I realized, well, this is a tech talk, right? And we wanted to rather cut the governance crap and go right into technical concepts and demonstrations. And I thought then we will just connect the dots while we do some tech talking, right? And that's what I'm going to do. And maybe part 1 and 2, we'll see about that. So my main thesis for this talk is basically that sovereignty is not just declared, right? Instead, I like to think of this mathematically precise formula, if you will, where sovereignty must be built with technical interoperable capabilities shared by many, sometimes even competing market players that then form an ecosystem. So in fact, maybe almost 3 years ago, more or less, an important project of common European interest on the topic of next generation cloud infrastructure and services, in short, IPCEI-CIS, well, that's how I pronounce it, was launched. That is across 12 member states. And if I remember correctly, there are like more than 120 companies and research institutes that partake in this. Now, together with IPCEI-CIS and IPCEI-AI, these initiatives, these European initiatives, are projected to mobilize around 8 billion euro of public and private funding and investments. So we're not talking about peanuts here. And the goal is more or less of these initiatives to motivate Europe's digital ecosystem to build a so-called interoperable multi-provider cloud edge continuum. So I like to rather explain it in layman terms. The EU came to the conclusion that the digital services industries in Europe are fragmented so badly that they stand no chance against the winner-takes-it-all platforms on their own. And these policy instruments basically motivate the industry to work together on a joint mission. And if you want, you can read up more on this on aura.com. The O is, spelled like an 8, the infinity symbol. And yeah, and now I previously led that SAP's project for the IPCEI-CIS, which we named Apiro reference architecture. But more importantly, I was also the lead who motivated the formation of the NeoNephos under the Linux Foundation Europe, and the donation of all Apiro components under open source and vendor-neutral governance. But that is a content for another talk, as I said. Instead, let's go technical. And now I understand that I underlined the term next generation here in this slide for a reason, because the IPCEI-CIS funds expect fundamental investments into innovation. And ALASCA, you are well aware of the NeoNephos project Gardener, previously known as SAP Gardener, of course, because you collaborated and built YAKE for it. And of course, you know everything around infrastructure. So therefore, and because there are more projects under NeoNephos, some of which are maybe less known precisely because they are next generation and net new, and the teams that are building them are collaborating only within the IPCEI, mostly. But since everything now is built on open source, you can also try it out, provide feedback, and contribute in code. So let's keep that in mind, because these net new projects are also part of the Digital Commons. So I would like to show you a few of these net new projects. Okay. All right. So the first project I have for you is called the Open Component Model, available under ocm.software. And I will basically demonstrate to you 3 dimensions of this project, what it does. One is about packaging and transport, the second about deployment automation, and third is about security and compliance. But keep in mind that OCM is not just for cloud native software, it's really technology agnostic. And I rather like to think of it as a coordinate system for software products, right? So there are multiple other dimensions that it can also help build, and we'll be seeing that in detail. So let me talk first about the conceptual software supply challenges first. So if you have a development team, if you have a product company, your product is built by a dev team. And typically, you also componentize your product, and you might have a pre-product. You might even have that pre-product might have a library coming from an open source ecosystem. You might have a different team that actually also collaborates with you and gives you a subcomponent that a different team is responsible. Or you might even completely bind to an open source product that you consume by an outside, somebody else outside your company, and you get the support by some partner. So essentially, this is what I call the fan-in of the software bill of material. Yeah, so this is typically known, that you need to know that. And then on the other side, if your product needs to be produced as a service on a cloud, you typically have a DevOps team that might be well integrated with your dev team, or it might also be something like an SRE team. But in general, your organization basically says, hey, you build it, you run it. But more often today, we come to the fact that your product needs to be run on somebody else's cloud, right? And you can help them run it, but essentially you just build it, somebody else runs it. And if you go to really sensitive areas, your product is actually run in an air-gapped maybe environment where only security cleared personnel can run it, right? So you don't even get access to your service once it's running. So here we are talking about the fan out of deployment automation, more or less, right? And in order to ship your product, you need to package and transport it, even into clouds. Yeah, you have to have some form of a release, and more or less you have to, before you ship and release a product, you have to check its security posture and check all the legal compliances and whatnot, right? And if you take a look at the lifecycle management tool ecosystem, they do not cover all of this end to end, right? Most of the standardization stops at the border of the product. So SBOMs, containers, and so on. These are all language-driven standardizations, but in the end, how you deploy things, how you do security and compliance is left to the product teams or the product organization. And what we find more or less depending on what the DevOps team has done previously, you have different notions of how a product is basically put into production, right? Some may use Ansible, some others may use Terraform, and the modern cloud native guys rather use GitOps. I mean, there's a lot of variability here. So in order to reach more or less the mission statement for the Cloud Edge Continuum, we need standardization reaching end to end. And for that, I'm basically saying that you need to shift left of all these deployment, security, and compliance concerns. It has to come from from those guys who produce the product. And I don't mean basically shipping a mechanical Turk where somewhere in the hidden chamber, there's still a human personnel, or nowadays a large language model maybe, right? That's not what I mean here, all right? And so what I'm going to demonstrate, where I'm going to go down to the CLI level, is I'm going to take the conformance test scenario called Sovereign, which is basically built into the Open Component Models test harness. So what we're going to do here is we're going to build the product. I'm going to create basically a common transport format. That's what it's called, CTF here. I'm going to sign it, and then I'm going to place that product in the archive, transfer it more or less onto my USB stick. I'm not going to do that. I'm just going to simulate it into an air-gapped folder, if you will. And I'm going to import everything that I need into an OCI registry on my local client cluster. And I'm going to then verify that everything that I ship is really signed by me. And then I'm going to also automatically deploy it, right? And this is how our product looks like. It's basically a product that consists of Postgres. Postgres has a container and a Helm file, and my application is called Notes. It needs also a Helm and container, and it has some metadata around open API specs and ORD documents, which is not of concern. And then the product itself, we typically advise you to build an operator for this, but the poor man's solution is, and you'll see how this comes together, we're going to use a resource graph definition using Crow, right? And we now will build the OCM component around this, and it'll be utilized like a release channel for you. And then we'll package and transport it, and we'll automatically deploy it. But what's more important here, in the end, we will automatically ship a new version with automated lifecycle management. Okay, so without further ado, if you want to follow it along, it's under the folder Scenario Sovereign, and there's a README file and so on. That's what I'm going to do. Okay, so I'm going to switch to my CLI. Is that visible? I hope the switching was visible. You see?
Yes,
Yeah.
that works.
Yeah, that works. All right. So what I did more or less in before is I already created my cluster setup. So here's my kind cluster with all a couple of components, and I already cached the full demo because it takes a while to download and so on, and I reset it. All right, how does the OCM component constructor for the product, the high level thing that orchestrates the subcomponent and so on look like, right? So let's go through the YAML file a bit in more detail. So it has a name, it has a version, and basically you state who are you as the provider of this project. It makes sense because when you sign it later on, that name should, it doesn't have to be, but the name should be somehow in the certificate, the signing certificate. And then we basically reference subcomponents. Notes, yes, and Postgres as an open source component is a subcomponent. And the only thing that at this level of the hierarchy we put into the model is my poor man's solution of the operator, right? The RGD definition for crow, right? Then let's take a look at the component constructor for Postgres. Same thing, some name. We used version 1.0 for everything except for the real Docker image here. And what you see here is we are referencing a Docker IO hub image directly. It's an external image, right? And the Helm chart below. And the same goes for the sovereign component nodes, right? But here, I basically built it on my laptop, and I exported the Docker container into a nodestar.gz file. There are ways how you can do that. It's very nice to do that because then you can also include these types of functionality in your build pipeline, more or less. The rest we're going to ignore. So as I mentioned, I already executed the build, and this is basically the CLI instruction to actually create the nodes component and place it into an archive folder called transport archive, right? Once you do that, let me execute here. Oh, this looks a little bit, let me see, can I make this smaller? Yeah, oh, right. So I hope this is still visible from the font size. Okay, so what you see here is I just executed this adding of a component into this transport archive, and then I executed get me the resource for nodes version 1.0 in a tree format, and you can see that's my nodes component, and it includes a Helm chart, an image, an API spec, and an ORD, and the component itself it's not fancy, it's just a single component, there's no sub-references. All right. Now let's go and do the same for Postgres. And I did it. It's the same thing. In the build, I don't build the Postgres, but I just build the component. So let's execute that. And what you see here is basically the component itself. There's the Helm chart, and there's an image with version 18, and it's an external image, right? It points to the Docker IO environment. And lastly, now I'm going to build the product, the high-level component, the product component. Same command over here. The only difference is that I'm going to sign it with the with my key, right? What you see now is the high-level product component only has one ingredient, the product RGD, and it's locally included, by the way. It's not pushed onto an OCI registry or so, that file. And then, but the component product now includes two sub-references, just like I explained on the slide, right? Okay, so if you want to now look at the complete component, which we now signed and so on, in YAML notation, it basically looks like this. It's more or less, where's the signature? One sec. Further down, you see there's my signature of the product component. But what's more important here to say is it's not a signature of the full text. It's a normalized signature. So we sign the content that is behind it. So you can still add things into the textual area of the component descriptor. So for example, you can use it like a routing slip. You can add annotations and things like that. The important thing is that the content is signed. And that becomes important when you transport things, because we do not sign the location of the artifacts that we reference to, but only the binary blob, if you will, right? And this looks just like a YAML file. And the first thing that when we actually talked to AWS GNU guys, they said, well, why don't you use Kubernetes format? You are living in a Kubernetes cloud native realm. So we just said, yeah, it doesn't actually matter. If you like Kubernetes YAML, we'll also generate a Kubernetes YAML for you. Yeah, because it's the same context, and I just wanted to display this because my argument for the coordinate system actually exposes an interesting dilemma. We are playing in different domains. One domain is the Kubernetes domain. Another domain is maybe the SBOM domain. And every domain that you take a look at has different specifications and different standards. But the argument that is more important here is that the OCM thing, it's not about the syntax of the standard. It's more about the semantic information that we place into it, and we can generate the standard that you want. Yeah, and most probably we are seeing most attachment to the so-called SBOM arena. We are probably going to migrate the standard into an SBOM type of environment. So this is, as mentioned, next generation. Things are evolving. So what we're looking at is already version 2 of these things. And yeah, your feedback is welcome here. So, all right. So now I have my component more or less in the transport archive, which I just set up with you together in my temporary folder. And I want to ship everything onto my USB drive and take it to an air-gapped environment. So what I can do now is I basically use the command transfer components. I do the copy resources recursively, and I go from the transport archive to the air-gapped archive. And this is basically the output you can see here. And I wanted to show you something, because I already did this, but I want to show you something important here. The important thing is that the sparse component definition, which points to basically external containers, is only 32 megabytes in size. But once you download everything from the internet, it's 1.1 gigabytes. So you can see there's truly something different here, right? And then I basically transfer this once with the USB stick. I transfer it into my local registry here. And so this is, as mentioned, very live. Oh, the font size is not good. Let me see. Yeah. Well, at least you can see here. One thing that you can see is I'm really executing these files against my local registry here. I transferred everything into my local registry. So if something is missing, then you will surely be able to see it. Okay, so now let's go talk to the next part, right? So what I did is I actually already installed the OCM controller kit onto my local cluster. And in order to basically reference and do the automated deployment here, I have to basically point my OCM kit towards that repository. In this case, it's a local registry, and the name is sovereign repo and namespace and so on, the usual Kubernetes stuff, just like Flux, very similar. Right? Actually, we run with Flux or next to it, if you will. And then I'm basically interested in a very specific component in that registry. So from the repository, I'm interested in semantic version 1.0.0, and I need to verify this with my key, with my signing key. Before that, I actually transported that key as well. That's what you also need to put onto your USB drive, but that PKI infrastructure, transport, that's something outside the realm, right? You can do it with or without. I mean, yeah. Anyway, and the interesting thing here is now in this example, I only pinpointed one version, but you can actually pinpoint your specific version that you want. Then you can automatically install patch versions. Later on, it'll become clearer how that works. Or you can also filter certain semantic versions, pre-release candidates, and so on. You can filter that. Typically also available, just like in Flux, right? And now, when we now want to do something, we're now pinpointing a particular resource in that component version, namely the one here, which we called product RGD. This should typically be an operator, but in this case, I'm basically using the Crow poor man's solution here. And that's what we're going to do. And the deployer here essentially installs whatever is mentioned under the product RGD here, right? So you basically ship that, and there are various different deployers you can do, but we actually advise you to use an operator, and you'll see in the second example or third example why this becomes important. So I'm going to now install this bootstrap, or you could also call it subscription. So we're subscribing to an OCM release channel here. So let's do that, and let's take a look at my cluster here. So if you take a look here, repositories, see that went in, and in the end, the deployer is the sovereign deployer. It just applied that version. And if you look at the CRDs, all of a sudden there's, I didn't show you before, but you have to believe me that before there was no definition of a CRD for a sovereign product, right? Okay, oops. Go back to the pods. And now basically the system is ready. Your OCM component is ready to deploy, but now you have to really do the deployment. And the deployment here, and this is how we or the colleagues of this test scenario chose it. They just basically said, okay, I want to be able to specify how my notes application should look like, and I want the Postgres database to be applied. So I'm going to just execute kubectl apply, and if we wait a few seconds, you can see already the Postgres is running. Take a look. And if you see here, the image is really coming from my local registry. It's not from the internet. And if it's not there, yeah, something is missing in your component description. So let's wait a few seconds. Indeed, everything is running. Hopefully, okay. So then let's take a look at that product itself. So I'm going to port forward and go to localhost. And that's my sovereign nodes product shipped into an air-gapped environment that I'm obviously simulating here, right? So works, even the Postgres database connection works. Okay. So I wasn't truthful to you completely. I only showed you the version 1, yeah, because if I execute this here, you will see that I actually already built the version 1.1, and I also the 1.1 gigabyte also includes that in the transfer, right? Because as mentioned, downloading 1.1 gigabyte would take a long time. So the registry is already filled with the new upgrade version. So let's upgrade to the 1.1 version, right? So it has been reconfigured. So let's take a look here. And the way how it does, I mean, this is just a sample scenario. We wouldn't need to redeploy the Postgres, but at some point, maybe a migration from Postgres to MySQL would be an interesting feed. And what you should be able to see in the logs, let me see, it's still the old version. I have to wait until the new 1.1 version is executed. There you go. So the way we built it, because the operator is a poor man's solution with Crow, we didn't have any place to put the migration code. But if you have a full operator in code, I mean, you can also use crossplane and the possibilities of compositions and so on. Somewhere you have to put the migration information and the migration code. And we chose to put it in the application itself. Now, what you can see here is, I think I chose the wrong part, but yeah, it basically did schema changes. So this is a complex upgrade, if you will, right? So it's now running as well. So let's, sorry, I have to, of course, port forward again. And now you can see that we added a different all right in open source. Yeah, I'm bad at typing. And now you can see we basically changed the product and we automatically shipped a new version. And basically the only thing I did here manually is to say, all right, I now want to upgrade from version 1 to version 1.1, right? It could have also been done completely automatic, right? All right, so that concludes my demo of the of the OCM component. I hope you got a sense of information or and a plastic view of how OCM actually works. But let's go further, right? I talked about security and compliance and basically said, well, it's not a good practice, even as open source entity, to actually ship your product without a security and compliance view. Now the CRA basically takes that obligation away from the open source steward, but if you're a commercial or somewhat semi-commercial company, you have to basically make sure that your product is tested against vulnerabilities. And for that, we have a sub-project called Open Delivery Gear. So a producer of a product can basically take a look at this product, connect extensions to all types of security scanners and connect findings and basically establish a compliance data lake. We'll see how that works. And now the developers of that product can now come in and basically assess all of the findings and basically say, hey, this doesn't apply, that doesn't apply, or here I have to fix it and whatnot. But all of that metadata can be packaged and be part of the product and shipped as part of the product. Now, why is that important? Because as a consumer, when you have operational obligations under NIS2, for example, the obligations actually transfer to you as an operator of a service, right? You want to basically be able to also scan your product. You're doing that anyway, because you want to trust, but you want to verify these things. And because of OCM, you're also to do this in an air-gapped environment. So let's take a look at the Open Delivery Gear. Okay. So this is basically the Open Delivery Gear usage, or let's say a UI. There's still in the first or second iteration, it's being used productively within SAP, right? But we are now working towards, with external feedback, what makes sense to put into a real open source project that can be used outside of also at other companies, and it's built for that, right? So what you can see is I've packaged a couple of extensions in here, and what I basically did is I took my project version 1.0, and this is the component descriptor here. And there's one interesting thing here, that it also provides provenance, because I took that that component descriptor and transferred it, and not with recursive copies, just a sparse component descriptor, and I basically transferred it to a different location, not into my local registry, but onto a Docker registry here, pointed over here. And more or less, the Open Delivery Gear is more or less a browser on these components, right? So you can see here, you can see the same thing on the product level. I only have this product RGD definition here. And below, we have the two subcomponents, notes and the Postgres. And what happened here is we let it scan with all the plugins and extensions that we have. And there's an interesting, one sec. Yeah, there's an interesting finding here. You can find out that actually the cryptographic libraries are not compliant if you want. The vulnerability, there are lots of CVEs that were found, right? So what a developer would do is they would basically start assessing all of these problems. In this case, for example, let me see the OpenSSL library here. I would or let's take the critical one, like the Open Golang. I would basically say this is not exploitable for this product on the component level. So it does, this assessment is not globally on for everyone, but on this thing here, I would say not exploitable, because I basically make a note and I would apply this rescoring with my name. So that is what is meant with compliance data lake, right? And so the interesting part is that even though somebody might use the same notes component, the same image, because the way how I did this, I basically said, no, it's only on the component level. It is not in global assessment, right? That the same component used in another product might have this issue as well. So all of these specific things can be basically configured, right? And the same thing over here, there's a license violation. So we also check legal stuff. In this case, it's the Sleepycat license from Berkeley DB. Our organization doesn't allow us to ship it. So in this case, we can basically say we cannot override it because it's an organizational setting. But if you're an open source organization, you can basically say, well, Sleepycat doesn't bother us, and so on. So also that is concluded. All of these findings, more or less, are now, we can basically take that, and OCM can also be used as a routing slip. And that's what we basically did. We basically shipped all of these assessment in a new version here. And here you can see in the 1.1 version, there are no more crypto findings because all of them have been assessed. And you can find here a metadata file called rescoring metadata that includes all of the developer or producer side assessments that are then available on the consumer side as well. We basically tell you, and it is signed information. So there's basically information, signed information about why certain vulnerabilities are not applicable. It's a similar thing like WEX, but here we give you on an information based on the development side of things, right? We might be able to also integrate it into WEX or something like that. And the same thing happens over here, right? For the Postgres component. Yeah, and this is, well, this was a sample project. Actually, there's we do this also with the full Gardener project. Like, so if you take a look at github.com, that's the name, Gardener. And there's a version. So let's reload that. So now you can see this is a serious project. This is how Gardener is shipped into air-gapped environments, right? And because I'm going to use it here, we also did a POC for the full OpenDesk component, right? So my colleague Stefan Kelch actually took the Zendesk project OpenDesk and basically created an open component modularization of this thing. And yeah, there are quite a number of vulnerabilities and license violations yeah. So this is a serious project that, in our opinion, makes sense also to have in the wider open source world. All right. So let's go back to the demonstration. And I knew that I would be forgetting this. I put a screenshot in here. So what in the examples, I only showed you basically containers, Helm files, and flat files, if you will. What you see here is we actually ship full Linux distros. So not in the open source, but in the internal Gardener that we use, we actually ship multiple versions of Garden Linux, our Linux distro that we use, into air-gapped environments. I mean, the Gardener project has multiple Kubernetes versions that in its packaging, and it also includes multiple versions of operating systems. So it's also SUSE C host and so on that we package, but the screenshot here only includes Garden Linux. So there are multiple versions here. All right. And the extensibility of OCM doesn't stop here. So there's one interesting example, because now there's a software bill of behavior. So if you look at, for example, the Kubernetes Storm Center, Constanze from Fusion Core is always trying to educate people that, well, we should actually not just ship static compliance information, but we should ship bill of behaviors. That means essentially assess the product as a producer and ship compliance and security information that helps, as a bill of behavior, helps the consumer of such a product to assess whether an attacker has actually come into the system and is using lateral movement and so on. And this is exactly one of the things that we can also ship with OCM. Yeah, think of it like a Beipackzettel in German, like a package leaflet. Medical products do not ship without such a package leaflet, and that's something we should be all aware of. You should actually say, this is how your product should be used in production. And if you see some alternative connections, alternative capabilities being used, this, at least warn your operator that, hey, there might be some breach here, right? And it's not rocket science. The rocket science is actually how you create these types of definitions of what is normal usage and what is not. But the format, in this case, it's also Kubernetes application profile definition, more or less. It basically says there are some intended capabilities, some executables that are typical in here, and you can also specify specific rules of what also can be allowed and so on, right? There's a lot of let's say intelligent work that you need to get that done in a proper way. And there are multiple ideas currently in the ecosystem under the name not only bill of behavior, runtime profiling, behavioral whitelisting, security as code, and the industry momentum and concepts around VEX, OBAUM, CDX extensions, SPDX profiles, and so on. And this is all fueled by EU in the EU, these are the ones, regulatory requirements under SCRA, NIS2, DORA, and so on. And it's not going to stop. So, yeah. Anyway, as mentioned before, I like to basically think of OCM as an independent coordinate system. So in the Unix philosophy, you basically focus on something that you do well and then be pluggable with other executables, if you will, right? And OCM here does one thing right. It basically gives you a coordinate system for shift left. And the only thing that it really, well, not only, but the one thing that it does good is packaging and transport with signature formats, right? Everything else is basically pluggable, yeah? And that makes it also a bit future-proof. right? You don't want something, monolithic specification that does everything, because then it's really hard to get new nuances and different viewpoints into it. Yeah. So I hope I was able to convey the first project, OCM and ODG, that we enable these types of things, and that we are essentially paying into next generation necessary innovations around interoperability. Now I'm going to talk about platform mesh around ecosystem building, right? And for that, the platform mesh project is available under Platform Mesh IO. And to understand this, I think I need to talk a bit about concepts. And now hopefully it will also be clearer why I mentioned why we advise OCM and the automated lifecycle management to contain an operator. So I hope this will become clear. So if you look at the generic concept of how people provide software as a service, right? Typically, a provider needs to be able to to instantiate an order execution system. That ordering execution system needs to be able to get the order from a consumer. It could be by fax, it could be by paper, snail mail. I don't actually care at this matter. It is conceptual, but obviously it should be in today's day and age, it should be available through an API, right? And this order execution system, however it does it, once it gets the order, it should be able to fulfill that order and create software as a service by exposing an API and an UI with all the things that are necessary, creating accounts and whatnot, right? So now we are talking about cloud native. We are talking about Kubernetes. So obviously the infrastructure or the runtime that a provider is using is Kubernetes. And if you think about the order execution system, that is more or less an operator, right? So the operator does that, does the fulfillment of the order once it gets an order. And the order is a Kubernetes resource modeled manifest. Basically, consumer uses kubectl to apply that manifest or that order. And that's what we just did in the example that I did before, right? So, and then the operator does the needful and gets the persistent volume claims and runs the pods and whatnot, right? So now let's see what an OCM-based software as a service ecosystem does to the posture of serving and selling. So let's take, for example, a product vendor like Zendesk, like the OpenDesk product. And let's imagine that they have placed a release channel with an OCM model around this, right? So an infrastructure provider could now subscribe to that release channel, and the only thing that he gets is an operator instantiated, right? A poor man's solution or a full-fledged doesn't matter at this point, right? So now he's ready to actually take in orders, right? So he can provide OpenDesk as a service, if you will, but customers have to come to him and basically through his maybe proprietary account system, place that order. This is where we basically say, hey, most consumers, and you'll see the other argument, they have an internal developer platform, because that's also where platform mesh plays a role. So instead of going to the provider, to the individual provider, we say, why don't you place the order in your internal development system that you want to have this piece of software installed? And we flip the ordering route and say, why don't the infrastructure provider pick up the order directly from the platform mesh instance with a contract, of course, from the consumer, and then instantiate, yeah, the OpenDesk instance here in this example. And because this way, the provider now easily can also serve multiple consumers or customers, right? And for the provider, it is very easy because he now gets to upgrade because he gets a safe release channel with automated lifecycle management for these types of provider instances, right? So think of it like on your mobile phone, you know, how often do you really check if the next upgrade is valid? Yeah, typically you just say, yeah, upgrade them all. I trust you, trust the provider of an application, of a product, that he's done all the checks. And typically they do, because they upgrade like 1% of their clientele first and then the 99%. So you're hopefully in that 99% and the upgrade goes through, right? Okay, so platform mesh in this sense also flips the coin in another direction, because if you think about consuming and buying, so from a consumer point of view, you might be very happy with your provider A in this case, but provider A might only be serving Central Europe. And you might have a situation where you want the product to be able to be instantiated in I don't know, the northern part or the southern part of Europe, and provider A is not available there. So it's very easy in this case, because a provider B, which serves that jurisdiction, is also able to essentially subscribe to the product and be able to serve that product and be able to establish contracts with the consumers. So the consumer can basically do his own scheduling and say, I want my order to be provided by A or by B, right? There's no more difference, right? And the last thing here is if you flip another time, you know, platform mesh also enables marketplaces, because a product vendor like Zendesk can now go around and say, who would like to be able to, or not who, but we will select a number of providers across Europe in the whole continuum, if you will, right? And they will, I will be able to deliver my product and my upgrades into different infrastructure or cloud providers. And I will basically expose a platform mesh instance for my consumers, for my accounts, right? They can come to me instead of going to different platform meshes, if you will, right? And this is not only one product. You might have every product vendor can do this. And if you talk about that, then you all of a sudden have marketplaces, which basically, well, maybe curate a number of products in the continuum, and they will keep the trusted connection with the consumer. And at some level, a scheduling definition is taking place that basically that gray order is scheduled towards that provider B or whatnot. So the interesting part here is there are lots of additional protocols I've seen. I mean, federation protocols, Tosca, and whatnot. What the argument here is, we are basically reducing the cognitive load down towards cloud native. Every machine room capable developer or Kubernetes capable DevOps team knows about cloud natives, can talk with kubectl, kube control, or however you want to name it. We are not applying an additional protocol on top. We're using exactly the tools that you are already familiar with, controllers. If you want Terraform and so on, you can, or Ansible, you can package it all into a pod and transport it with OCM and be happy where you're at. No additional protocol level definition. That's what platform mesh is about, right? And I can't give you a full demo of platform mesh here, but I can do something with screenshots here. So if you go to platform mesh and download the, let's say the starter kit or do the example, the interesting thing is that platform mesh needs a couple of more other projects that are included in here, that are aggregated here. One is the UI here is built with the open micro front end platform and with Luigi. And once you basically have it installed, the first thing that you do is you basically install an organization, or you create an you create an organization, in this case here, a default organization or demo organization. And what it does, it also ships Keycloak, but on account level, you can also plug in other ones as an OIDC provider, and it creates a full realm. So we basically take it to the whole scalability level, so that your organization gets its own Keycloak realm. Then within your, once you created your organization, you can create your customer accounts or your demo accounts in this case, right? It's a vanilla installation here. So there's not much, everything is pluggable, right? And once you create your account, you actually, I hope it's visible here, you can actually download a kubeconfig that gives you a kubectl access to your workspace. The naming, there's basically KCP integrated in here, right? And then once you do the full installation, once you add components like full service providers like a Gardener or Open Control Plane and so on, all of a sudden automatically on the side, your UI capabilities, what you can access grows, right? So on the UI level, it's integrated. But interestingly, it exposes another problem, because if you deal with hundreds of potential API servers, you actually need to project access controls into them, and RBAC, the integrated access control within Kubernetes, does not cut it, because you have to think about, okay, I have 2 API servers, 2 instances, and I need to set relations and access control between the relations. So we actually ship as the Zanzibar concept of OpenFGA within that platform mesh product, right? So that is also part of it. And and this screenshot here shows you that what I just showed you manually with OCM is actually installable in Open Control Plane with the OCM controller, the GitOps Flux and Crow and Crossplane, everything is there, and it comes with out-of-the-box UI components, right? And this is things that are being shaped, and your feedback could be well necessary for this. Yeah? And this is not just an experiment. We are actually collaborating with the IPCEI ecosystem. So the EcoFed is another Netherlands-Dutch consortia with a couple of companies. We actually integrated their EcoFed, their EcoFed services using an operator into our platform mesh. The telcos are doing the same. So with GSMA and Camara, there's a Catalyst project, also part of NeoNephos, which integrates into platform mesh, giving you the capabilities of onboarding devices. It's an internal feature between the telcos. And there's lots more happening there. Of course, the internal developer platform as SAP, not available to outside yet, but has a BTP operator. And yeah, as mentioned, we actually did a POC for Zendesk with OpenDesk. It actually works. We actually did a couple of different nuances of operator using Crow, using Landscaper, maybe a full-fledged operator would be better. But yeah, that we just did a POC here. And last not least, just earlier this week, you can take a look at the YouTube channel here. The IPCEI basically released the first information of a pilot for sustainable workload placement between SAP, Telecom, Emulate, Westfalenwind, and I think FH Dortmund, or Darmstadt, no, Dortmund, I think. So what they basically did is the SAP colleagues set up basically a platform mesh for everyone to collaborate in, and gave them workspaces, more or less. The wind park put a physical cluster underneath the wind turbine and established Kubernetes clusters there for workloads to be placed. And the colleagues at T-Systems did a smart, sustainable placement recommender, and the project Emulate has a CCAM recommender that actually is carbon aware and does the correct scheduling to the right wind park, if you will. And there are a couple of more APIs necessary. I can't delve into that detail here, but you can see on this level that this is not just talk, but we're really piloting things. And with that, I hope you were able to see that how, some of the projects that might not be visible today are placed under vendor neutral governance into open source, and they really help shape the ecosystem and interoperability posture of Europe. And with that, we basically help the sovereignty or digital autonomy question that we are working towards, right? Okay, so now to a quick outro, on a higher level concept, more or less the paradigm shift that we need to induce is the same as we saw, in when operating systems basically were put in as a middleware, because earlier on software and hardware were shipped as a unit, and the operating system were decoupled basically the hardware from the software, right? And today we essentially have the problem that cloud services are tightly attached to a cloud provider. And what essentially needs to happen is we need to we need to modularize and create a more or less a distributed cloud operating system. And the one that is being shaped today in open source is the cloud native ecosystem. And if we use that to create a distributed cloud operating system, we will get to a better sovereignty, because then everything can be placed on everywhere, right? That's the more or less the mission goal for the cloud edge continuum. All right, and the NeoNephos motivation here was, well, we all stand on the shoulders of the Cloud Native Computing Foundation, which started with the Kubernetes ecosystem. And what we did with the funding from the IPCEI-CIS and also our other members, which have applied to the AI and CIC initiatives, will be using those funds to actually create further projects under the NeoNephos Linux Foundation Europe. And the question we want to deal with is, what does it take to make cloud native sovereign? And more or less, it's about doing everything underneath the Kubernetes ecosystem, on top of the ecosystem, and on the side. And I've added a couple of mascots or icons in here that are not yet part of NeoNephos, but the colleagues from the Open Defense Cloud here with Arc and Solar and the Beaver mascots here, they will be contributing here as well. And they're basically building on OCM and on the other projects here that I don't have time to talk about. One more thing, because this question was asked many times. Guys, the Gardener project was placed into NeoNephos, but it doesn't mean that it has to be Gardener. We can use any type of Kubernetes ecosystem, right? Or provider, if you will, right? And with that, I would say thank you very much for the opportunity to talk here. And I'd like to open it for a Q&A round, if you're okay with that. Hope I'm not
Yes.
over time. I am over time, yeah, but
Just a little bit, but that's okay. We started late and it was a bit chaotic, so sorry from my side. Again, everything just decided to shut down on me at 10:59, so sorry about that. Thank you very much, Vasu, for that effortless and very great presentation. If anybody has any questions, shoot.
here's the opportunity. All right, if there's no Oh, Rankan is still typing. Let's wait for that. Otherwise, I mean, the session is recorded and I'm available through my email. You know how to reach me. There's actually Zulip chat where NeoNephos projects, OCM, and they all these projects have a community where you can join and ask questions in detail as well. Yeah. Oh, where you hosted your image in a local registry. Yeah, I can actually show you. One sec. Well, I created a Docker registry in, let me see, where is that? Go to the dashboard. There it is. There's the registry. I just hosted it locally. And I did some, well, the colleagues did some network shenanigans so that the registry is also available under the Docker name. That's how we did it. Okay, good.
Alrighty.
I will
If
then
nobody
stop
else has
sharing.
any more questions, again, Vasu, thank you so much. And I am just going to quickly share my screen and fly through, hopefully, if it lets me, fly through the events. Right. Right. I'm just going to go through everything in short. The SCS Summit is coming up. It'll be on May 21st in Berlin. The program has been officially launched and published, and it looks really great. So if you haven't gotten your ticket yet, I highly suggest you do so because it looks really nice. And I'm excited to announce that ALASCA will also be contributing to the program. We have a talk, a lightning talk. It'll be held by Matthias Büchs, and he'll be talking about how to deploy an SCS compliant OpenStack through the Yaook operator. And then there will also be a panel. It'll be on open source standards in everyday life. Is not the greatest translation, but works. And yeah, that panel will be moderated by Daniel Gerber, who's currently working here for ALASCA. And the guests from that panel will be Matthias Haag from Uhuru Tech, Maria Vaquero from Cloud and Heat, and Jan Klare from ASYSM, which is great to see that that's 2 out of 3 ALASCA members on that panel. And they, amongst other things, will be talking about the questions of why do direct competitors in the same market decide to work together on SCS standards, which is, of course, plays into that whole topic of collaboration beyond bounds, which is something that's really important to us here at ALASCA, which is great. And I'm really excited for that panel. Other than that, I want to remind you guys of the hackathon that we'll be having. It'll be on July 1st and 2nd in Stuttgart, Vaihingen. Same setup and scenario as we did it last year. And registration is free. We would love it if you could join. Registration is just, for a head count of people, and you can do that via the link, or of course, you can find all info on our website. And what we want to do there is just 2 days of hacking, also community building, of course, and we just want to further develop our open source projects. We want to give a little bit of extra focus on our SCUM project that we have right now, which is a Sonic community build that we're trying to build up from the ground within our ALASCA community right now. And then we'd like to focus on some overarching topics such as an AI policy or security issue workflow. Right. Again, everybody is invited. We'd love it if you joined. The evening of the first night will be the Uhuru Tech Summer Party again, and we're all invited. So we already have a good evening plan. Right. Other than that, really fast, Alaska now has a podcast that was officially launched 2 weeks ago, I think. It's called Alaska OpenSnack, and it's supposed to be a podcast from and for the open source cloud community. And what we really want to do with it is just create a space for people to come together and have unscripted and open conversation on topics all around Kubernetes and OpenStack and everything that really is interesting to the open source cloud community. You can also find all info on that on our website. And we're excited if you want to give it a listen. We've already published one episode, and you're very welcome to listen to that. And then very lastly, I just want to hit you with the call for contribution again for the Alaska Summit. It's open until July 31st. We're taking lightning talks, presentations, and workshops again. And if you have a project, a use case, or lessons learned, then we'd be really excited if you would turn that in. You can find all info on the Alaska Summit website, or you can follow that QR code. Yeah, however, which way is best for you. With that, the last thing on our agenda would be to announce the next Tech Talk, which will be on May 29th, and it'll be held by Tassilo Tanneberger from DDIX, and he'll be introducing the new Alaska project I expect to us. And the title of the presentation is Continuously Monitor Your IX Peering LANs. All right, that was it. And thank you so much for joining. This was a little bit longer than usual. And with that, I'm going to send you all to lunch. Thank you so much. Bye.